Hi everyone. So today we are going to study the class 12th of Australian curriculum.
Hello,
Hi Fiona,
how are you?
I'm good. How about you?
I'm good too.
Okay, so what we are going to study today?
Um, we can start with the next the next chapter,
Okay,
or we can do revision for KSP.
okay, no problem. We can do either.
Wait, is like KSP harder or is K what was it? There was solubility and then there was also equilibrium. KEQ. Yeah. Which one is harder?
They are more or less same. Like they are the same topics. Like you can say
Same
uh,
topics.
same topics means like equilibrium is a chapter, right? In which we study
Yeah.
different kind of equilibrium. And in that, we have a
Mm-hmm.
subtopic that's called solubility. So,
Yeah.
you can say like solubility is a part of this equilibrium chapter. Okay.
Mm.
Hmm.
Yeah.
Okay. So we can do the
Can
revision.
we? Yeah.
Okay. Or anything else.
No, just KQ revision.
Okay. So can you see the PDF? I think I shared with you.
Mm-hmm. Yeah.
Okay. So we'll do from the starting.
Um, can we do instead of like starting, can we do the um
Hmm.
like the questions instead?
Yeah. No problem.
Like
We can go to the.
KQ based questions.
Mhm. Okay. So in the starting of this chapter, we have go through the equilibrium, right? So equilibrium can be
Mm-hmm.
achieved in the closed container or in the closed system.
Yeah.
Okay, so then we have discussed different kind of equilibrium and how to make the graphs. I think we have discussed these graphs, how the reactant concentration decreases and the product concentration increases.
Yeah. We can also do graphs. We can also study graphs if you
We
want.
haven't studied graph.
Graphs was also graphs is also hard.
Hmm. Okay, how much part we have done?
Um, what do you mean?
Like last time, what did I teach you?
Last time we did the module 6. I don't know the name of the topic. Is it acid and base reactions?
The acid-base
That's what
reaction.
we did last time.
Have we done this part? The equilibrium law, how to write the equation, reaction quotient,
Oh yeah.
right? Huh?
Yeah.
If reaction is given to you, can you write this reaction quotient? This is like a Q, like product upon reactant, the product raised to their
Mm.
powers upon the product reactant raised to their powers. And we also have done this
Yeah.
part. If Q is less than K equilibrium, then the reaction will move in the forward direction. And if Q is greater than K equilibrium, then it will go in the backward direction. Do you
Yeah.
remember this? Hmm? Okay.
Mm-hmm.
This is how we write the K equilibrium, right? There are some examples given here. If reaction is given, how we'll write the K equilibrium? This is our reaction, and 2O4 gas is in equilibrium with the 2NO2. Okay, so the
Yeah.
K equilibrium formula is product upon reactant. So what is the product? That is NO2, right?
Mm-hmm.
and raised to their stoichiometric coefficient.
Square.
Square
Yeah.
divided by reactant. Reactant is 1 mole.
And
It's so the power of 1. So we can write like
mm-hmm.
K equilibrium. Okay, so then we also have done for this heterogeneous equilibrium system. Do you know what is heterogeneous and homogeneous?
Homogeneous is wait, heterogeneous is like mix of two different. No
No.
way.
See, just like in the last example, the both reactant and products they are in the same phase, right?
Mm-hmm.
Both are in the gaseous phase. But when um, either reactant or product is in a different phase, or they are not in the same phase, then we will say the heterogeneous equilibrium. When they are in the same phase, homo means same, right? Homo means same. So homogeneous means when they are the same phase, they will be called as the homogeneous equilibrium. When they are in the different phase, that will be called as the heterogeneous equilibrium. Just like you can see here, this product, sorry, this reactant is in solid state and the products are in aqueous state.
Yeah.
Okay. So when we write the equilibrium constant for this, we will assume that this CSO4 it is in solid state. So there will be no change in its concentration.
Yeah.
Okay. So that means when we write the K equilibrium, what is the formula for K equilibrium? Product upon reactant. So product is Ca2 plus concentration multiplied by SO4 2 minus concentration divided by re- reactant. That should be like
Mm-hmm.
this CSO4 solid. But
Yeah.
as we say, this solid concentration will not change, right? The solid will not take as a part in the concentration. So we just assume the it is as a 1.
Yeah.
Okay. So the remaining portion will be our the K equilibrium, just the product part.
Mm-hmm.
Getting my point?
Yeah.
Okay. For this, if I have to write, how will write?
Um, so it would be PB2 plus in a
Okay.
bracket.
Hmm.
And then in another bracket it would be I minus and then 2 squared.
Yeah, square.
And just that.
Okay. This part will not come because it's a solid. All right.
Yeah. Mm-hmm.
Okay. So then, okay, here are the some of the problems which we can do. Like, would you like to
Yeah.
try some of the
Sure.
questions? Hmm. Okay. Let's try for the first question number 5. We have to write the
Okay.
equilibrium expression. So you will try part C and D.
Yeah. Yep. So D is 1 upon AG plus in a bracket squared, and then
Hmm.
CO3 2 minus in a bracket.
Okay, good. And what is
And
D?
then D is so H2O squared,
Hmm.
and then Cl2 squared,
Okay.
and then HCl to the power of 4,
Okay.
and then on the bottom, and
Yeah, yeah,
then
yeah, yeah.
O2.
Good. Okay. So this question number 2.
It will move in a forward direction
Why?
because the concentration is lower than the KQ concentration. So to achieve that, it will like move
Like
forward.
it's not the concentration, it's a quotient. Quotient means like
Oh,
Q, right?
yep.
So
Yeah.
Q is less than K equilibrium because K equilibrium is this much,
Yeah.
right? So when it is less than, it will go in the forward direction, right?
Yeah.
To attain the equilibrium. So that means the concentration of CH4 and H2O will increase because it is moving in the forward direction, isn't it?
Yeah.
Hmm. Similarly, question number is 4 also is a similar kind of questions where K equilibrium is given 0.46 and reaction quotient is 1.2. So in this case, Q is greater than K equilibrium,
Yeah.
right? So what will happen now?
It will move backwards.
It will move backward. All right. And I hope
Mm-hmm.
you can write the expression as we already done for the others, right? So these kind of
Mm-hmm.
questions come in the exam. Okay. Now the okay, next topic is the how dependency of the equilibrium constant on the equation. See, this is our equation N2O4 forming the 2NO2. All right. Now, if we divide it, if I reverse it, like NO2 is this side and N2O4 this side, like this,
Mm-hmm.
isn't it? Then the K equilibrium will also be reversed. It will be inversed,
Yeah.
isn't it? If I this is our initial equation. If I multiply it with the two, then what will happen? The whole K equilibrium will become the square.
Yeah.
And if I
Mm-hmm.
multiply with half, then the whole K equilibrium will multiply with the power will be half.
Yeah.
Getting my point? So this is how if we change the coefficient, then our K equilibrium, the equilibrium constant will also change, right? So they are written like this. If the coefficient of an equation are doubled, then value of K equilibrium is squared. If coefficient of the equation is halved, the value of K equilibrium will be the square root of the original value of K equilibrium. All right.
Yeah.
So this that's
Mm-hmm.
why it is important that how we are writing the stoichiometric coefficient, right? The different coefficient. Hmm.
Yeah.
Okay. So here this is the extent of reaction. How the value of K equilibrium define the extent of reaction. What is the meaning of extent of reaction? That how much it has completed. Let's say we
Yeah.
have any reaction, the same reaction which we have studied earlier, and O4 is forming 2NO2, right? Both are in gaseous form. This is homogeneous equilibrium. So if K equilibrium for this equation, if it is if it comes between 10 raised to minus 4 to 10 raised to 4,
Yeah.
okay, if the value, if it lies between these two values, 10 raised to minus 4 to 10 raised to 4, that we can say that at equilibrium, both reactants and products are present. Huh? So
Mm-hmm.
there here, the extent of reaction is significant. Appreciable concentration of both reactants and products are present at equilibrium. And if K equilibrium is less than 10 raised to minus 4, so 10 raised to minus 4 is very small value, isn't it? And if the K
Yeah.
equilibrium is coming lesser than that, what it means? See, when we write the K equilibrium formula, how we write for this equation? NO2 square divided by N2O4, isn't it? The upper
Yeah.
part, the numerator part is the product, and denominator is a reactant, isn't it? So when we say the K equilibrium is less than 10 to 4, 10 to minus 4, that means its value is very small. Or we can say the product is very small compared to reactant, isn't it?
Yeah.
Hmm.
Mm-hmm.
So that means we can say the reaction is just started. So reaction is just started. Getting my point?
Yeah.
Mhm. Or we can say reaction just started or negligible reaction occurs. Negligible reaction occurs if it's very small. And if it is very large, K equilibrium is greater than 10 is to 4. So 10 is to 4 is 10,000, isn't it? So if it is greater than 10,000, 10 is to 4, that means what? The product is very much is in very high concentration in the reaction, or we can
Yeah.
say reaction is almost complete. Reaction is almost complete. So this is called how we find the extent of reaction by seeing the value of K equilibrium or equilibrium constant. Did you understand these 3 points?
Yeah.
If K equilibrium is less than 10 to minus 4, its value is very small, then we'll say reaction is just started. Why? Because reactant is in very high amount. That's why its value is coming very low. If K equilibrium is greater than 10 to 4, that means product is very in high. It's in very high concentration. It's very in high amount. Or we can say the reaction is almost complete. There is no reactant in it. It's almost every reactant has converted into the product. All right. And if value is in between of these two values, 10 to minus 4 and 10 to 4, then we'll say the both reactant and product they are in appreciable concentration in the equilibrium. Got it?
Yeah. Wait. Yeah. Mm-hmm.
So these are the three principles to justify any reaction, that how much it is completed or not. So you will see the value of K equilibrium, and by that you can understand that what is the condition of equilibrium. All
Mm-hmm.
right,
Yeah.
got it? Hmm?
Yeah.
Okay. So effect of temperature on equilibrium, that how the temperature um, affects the equilibrium. So for this,
Mm-hmm.
um, there we use a delta H thing. Do you know exothermic reaction, endothermic reaction?
Yeah.
Hmm? So endothermic reaction. What is the definition of endothermic reaction?
When the reaction absorbs heat.
Yeah, endothermic means they absorb the heat. So that let's
Yeah.
say if our reaction is like this, A plus B is in equilibrium with the C plus D. So if it is an endothermic reaction, that means delta H will be positive,
Yeah.
right? So if it is absorbing heat, that means heat will come on this side, the reactant side,
Yeah.
isn't it? So
Mm-hmm.
do you remember that? I think last year or this year we have done the Lee-Chatelier principle,
Yeah.
right? So we'll use that principle here. Either we can use that or directly we can just memorize these two conditions. How they are formed? See, if we increase the temperature, what will happen? Heat will increase,
Yeah.
right? So the system or the equilibrium will try to maintain its equilibrium, right?
Yeah.
By reducing the heat,
Mm-hmm.
is that it? And how it will happen?
It will
By moving in
go. It will go forward. Uh, wouldn't it move forward?
I wrote it wrong. Hmm. So if increase the temperature, heat will increase. So by moving in the forward direction, this heat will
Yeah.
decrease,
Mm-hmm.
right? So that means as reaction moves in the forward direction, what happens? The K equilibrium will increases,
Yeah.
right? So we'll say that if temperature is increased, that means the K equilibrium will also increase for the endothermic reaction. All
Yeah.
right. And if it is
Mm-hmm.
exothermic reaction, then how will write A plus B will form C plus D. And exothermic means the heat will be released. That means it will
Yeah.
come on the product side. So if we increase the temperature, then heat will also increase. So to reduce the heat, it should go in the backward direction. That means K equilibrium will decrease.
Mm-hmm.
Okay, so these two things they had written here. If the exothermic reaction, if temperature increases, K equilibrium decreases, which we got here, right?
Mm-hmm.
If endothermic reaction, if increases, then K equilibrium will also increase.
Yeah.
All right.
Mm-hmm.
So these are the few points, and we are just doing some kind of revision so that we can do numericals based on this. Okay.
Yeah.
Hmm. Okay. Question number 3. Um, You will do part A and part C.
Yeah.
It's like a changing the coefficient kind of thing. Hmm.
Oh, okay.
Right?
Mm, yeah. For A, it would be 6.8.
For A. Okay, so
Yeah,
it's
for
a,
A, 6.8.
yeah. So you just have to multiply with the 4,
Yeah.
right? So that will become 6.8. Yeah, good. And for C,
And, and for C, it would be wait. For C, it would be 1.18. Wait, no. Oh, okay, no, it would be 0.85.
because you just have to multiply with the half, right?
Yeah,
And if
yeah.
it is B, question number B, then
Then you just do 1 upon 0.85.
yeah, good.
Yeah.
Okay.
Yeah.
Hmm. Okay. Question number 4, quickly. So they asked us, in which of the reactions would there be substantially more products produced compared to reactants?
More products.
Hmm.
Yeah. C,
Why?
because it's the lowest,
So,
smallest.
so,
And that means that the products, no, the reactants are higher than the product. Wait.
but we have asked about the more products.
More products. Wait. Oh, okay. It would be B.
Okay, simple formula. K equilibrium is equal to product upon reactant,
Yeah.
right? So we want product more. That means K equilibrium will be also higher.
Yeah.
So that means option B. Okay. Hmm.
Yeah. Yeah.
And this is like last thing we did with the temperature. Okay. So if this is A, what will happen
Okay.
if we increase the temperature,
If we increase the temperature, it would go in forward direction.
right?
Yeah.
So they asked us the equilibrium constant for each of the following would be increase or decrease. So that means K equilibrium will increase,
Yeah.
right? Endothermic, for endothermic, if we increase the temperature, K equilibrium increases, and for exothermic, if we increase the temperature, K equilibrium decreases.
Yeah.
All right.
Mhm.
So this is like a K equilibrium thing. Now I think next part is solubility. No, still you have some of the calculating part. Okay.
Mm.
So have we done this part? Okay,
Yeah. It was on my exam.
we have done this.
Yeah. It was in my exam.
Okay. So then better I should move directly to the solubility part, right?
Solubility? Sure.
This is also we have done Lee-Chatler principle, right?
Yeah.
Hmm. Lee-Chatler is done, changing temperature. Yeah, this is solubility and equilibrium. So And in this also, I think we have done some of the portion of it.
Yeah.
Definition of solubility, right? How much amount of solute or substance is dissolved in a given amount of solvent, it will be called as a solubility, right?
Yeah.
So there are certain rule for the solubility, like how when they are soluble, when they are not soluble or insoluble.
Yeah.
So this we have read that if the soluble in water, if concentration is greater than zero point 0.1 mole per liter, right?
Yeah.
Hmm. So these are the most of the chlorides, nitrites, ammoniums, all sodium, potassium, all acetates, most sulfates, they are soluble in water,
Yeah.
right? Who are insoluble? AgCl, AgBr, AgI, PbI2.
Yeah.
Similarly, Sr, Ba, Pb, SO4.
Mm-hmm.
Okay. And for slightly soluble, PbCl2, PbR2, CSO4, AgSO4. So you can remember like this. Most of the Ag compound, most of Ag, Pb, right? Ba.
Yeah.
And so they are insoluble in water or slightly soluble in water.
Yeah.
Okay. So by that you can remember. And their calculation will be the same as we have done for the equilibrium part. Here also
Yeah.
they have given some more ionic compounds, just like which are the insoluble and soluble and like slightly soluble. Again, you will find here Ca and Sr.
Mhm.
Okay. Mm.
But do you have any tips on how to remember all the soluble and insoluble?
Um,
Because they don't give it in the exam.
okay, so there are very few of them you can remember directly. Just like for Ag, we have um, AgCl, AgBr, right? AgI. Okay,
Yeah.
these three are insoluble.
Yeah.
And for similarly, other, except these SrSO4 and BSO4 and PbSO4
Yeah.
and is a PbI2. So these are the insoluble one. So all insoluble I have written here. Okay.
B.
And if we talk
Yeah.
about the slightly soluble, then PbCl2, PbBr2, and CSO4 and Ag2SO4.
Yeah.
So the upper one they are insoluble, and these
Mm-hmm.
are slightly soluble, or sometimes they are also called sparingly soluble.
Yeah. Maybe CO2. Yeah.
Okay.
Mm-hmm.
There are certain tricks, but um, because they are given a lot of compounds.
Yeah.
And for this, I think you just have to remember for the slightly soluble, CaOH whole twice and SrOH whole twice. So just add two more here, CaOH whole twice and SrOH whole twice.
Yeah.
So these things you can remember. Insoluble are mostly Ag, Sr, Pb. Even in the slightly soluble, you can see you will find them only. Pb, Ca, Sr, isn't it?
Yeah.
So by seeing them, we can recognize like where do lie. I mean to say it is a soluble or insoluble. Just like here,
Yeah.
we can see few examples. Determine whether a precipitate will formed when a solution potassium chloride and a solution of silver nitrate are mixed, and if so, identify the precipitate. So you are mixing. What are those two compounds? Solution of potassium chloride. What is potassium chloride? KCl. Okay, and
Mm-hmm.
silver nitrate. Silver nitrate means AgNO3.
Great.
So when you mix them, what will
Yeah.
form? AgCl plus KNO3.
Potassium.
Hmm?
Yeah.
Okay. Actually,
Mhm.
when
Yeah.
they are mixed together, they exist in their ions like Ag plus, Cl minus, K plus, NO3 minus.
Yeah.
Uh, but this AgCl they can combine together, and just now we have read insoluble compound. AgCl is a kind of insoluble compound. Do you remember?
Yeah.
Ag has three:
Yeah.
AgCl, AgBr,
AG.
and AgI. So all three are insoluble. Okay, so they will form AgCl, which is an insoluble compound, and the precipitate of silver chloride will form. Which is insoluble, they will form the precipitate. Do you understand the word precipitate?
Yeah.
Precipitate means like they will
Um.
get settled down at the bottom of the test tube,
Yeah.
right? A kind of particles or
Yeah.
so that's what precipitate. So here we can say the HCl will form the precipitate. Got it? Hmm.
Yeah.
Now for this, try this one.
NaOH and wait. What's the equation for acetate?
Acetate is this one. CH3COO minus. This is called acetate.
Okay.
So
BA.
it will become NaOH, right?
Yeah.
How will form the barium acetate?
BA.
Ba is 2 plus. So
So
this
so the acetate gets a two charge.
so BaCH3COO whole twice.
Yeah.
Okay, and
Mm-hmm.
they will react. What they will form? BaOH
Um. Oh,
whole twice
yeah.
and
And
CH3COO
A.
Na.
Um.
Okay,
The barium hydroxide precipitate.
yeah, barium hydroxide will form the precipitate. Hmm. Just like you can see here, insoluble in water.
Yeah.
Huh? Most hydroxides, most carbonates, right? Most phosphates, most sulfides. So most of them they will form the precipitate. Hydroxides, carbonates, and this all. This. Okay,
Oh, it says that barium hydroxide is soluble.
where?
Go to the table. Um,
Oh, where?
it says exception.
Yeah. It's a exceptions, na? Yeah, exception they are written here. So these are the like. Now this is like a nothing like a kind of a trick for it. I think they will give some table or for it. Which
They
one is
won't.
like they want.
I asked him. Yeah, he said that they won't.
Hmm. Then what your teacher told you that to
He
memorize
said
this?
you just have to memorize it. Yeah.
Okay, so then I will find some trick to memorize them. Then it will be easy for them. Okay.
Yeah.
So for
Thank you.
right now, just
Yeah.
we can use the table, and mostly in the next class, I will teach you the some kind of trick. How can we remember them? All right.
Yeah.
So this
Hmm.
BOH equal twice is
So
our
is the precipitate sodium acetate?
yeah. So BOH whole twice is soluble. It will not
Yeah.
form the precipitate.
Yeah.
Okay.
Mm-hmm.
Okay. Hmm. Let's do this. Which one will form the precipitate or not? Which one of the following substance would you expect to be soluble in water? So just make them and use the table. Sodium sulfate will be
And
Na2SO4.
yeah.
Lead carbonate,
PbCO2. Oh,
PB,
CO3.
PbCO3
CO.
simply because
Yeah.
Pb also 2 plus, right?
Oh, yeah, yeah.
Magnesium
Mm-hmm.
hydroxide, MgOH whole
It's
twice.
two. Yeah.
Silver nitrate, AgNO,
AgNO3.
iron third chloride, FeCl3,
Pb3.
barium sulfate, BaSO4,
BAP. Oh, isn't it
ammonium chloride.
phosphate?
Oh, sorry,
You.
phosphate. I read it
Yeah.
wrong. I read it wrong. So it will become what? Ba3
BO,
PO4
BO, yeah,
whole twice, right?
yeah, yeah,
And ammonium chloride, that is NH4Cl.
CO,
Potassium carbonate, K2CO3,
yeah,
right? Silver sulfide, मतलब
uh,
Ag2S.
yeah,
Calcium acetate, that will be
C, A,
CaCH3
CO, C,
COO whole twice.
yeah,
Okay, sometimes they written like this, or you can also write like this: CH3 COO whole twice Ca.
doesn't matter.
Yeah, mostly they will write like this. Just like we
Okay.
write CH3 COO Na, isn't it? Hmm?
Mm-hmm.
So now we just use the table and we have to find out the which one is soluble and not. So just go through the insoluble part, right? Right. So
Yeah,
which one is insoluble? So you can just say this is insoluble or form the precipitate. Others are obviously soluble.
yeah,
Hmm. Okay, so just you have to form the compounds. Like what is the formula for them, and use the table.
yeah.
Okay.
Mm-hmm. Yes.
Okay. Now comes the calculation part of the solubility product.
Mhm.
So this is a like this is our equation. All
Yeah,
right, and we can write the K equivalent like this. So when we have the what do you say like these compounds which form the precipitate, compounds which form the precipitate like AgCl. So it will form Ag plus and Cl minus. So as I
yeah,
told you, it's a heterogeneous equilibrium because it's a solid part. So we will not
yeah.
consider this part, or we will take it as a unity, right?
Mm-hmm.
So this K equilibrium will
Is
become,
the is the equation in solubility always heterogeneous?
yeah, because solubility, we are defining the solubility product for what? For the insoluble compounds. And insoluble compounds, they will exist in solid state, isn't it?
Yeah,
And for solid state, we'll use the simply uh, unity for the concentration, or we'll neglect
yeah,
that part. So this part will always come. So this is called solubility product. Solubility product.
yeah,
So the Ksp will be concentration of Ag plus and concentration of Cl minus.
yeah.
Hmm.
Mm-hmm.
So the product of concentration of the individual ions of the strongly soluble salt in a present particular solution, whether it is saturated or not, is called the ionic product. So what it means? Um, okay, so here we are going to study two kind of thing. One is called ionic product, and another is called Ksp.
Yeah,
Okay, so Ksp means when we write using the equilibrium part and all these things. And ionic product means simply multiplying the ionic concentration of the ions. Okay, what it means? See, just like we are writing for the expression for the copper second hydroxide. What is copper second hydroxide? CuOH whole twice.
yeah.
Okay, now if it is dissociate, what will happen? Cu2 plus and 2OH
Two.
minus.
Yeah.
And this is solid part.
Mm-hmm.
Okay, and this is aqueous. This is aqueous.
Yeah.
Fiona, our meeting is going to end. Can you rejoin it? And then we'll
Yeah.
discuss it.
Mm-hmm.